Good evening and welcome back to the Scientific Adventures of Beardman. Today we're going to take a look at significant digits. Right now we're going to focus on how to tell which digits in a number that's been given to us were actually measured, and therefore how many significant digits there are. We have 4 rules that we're going to follow. The fourth one has 2 parts. First rule: all non-zero digits are always significant. So anything 1, 2, 3, 4, 5, 6, 7, 8, 9, if you see that number, it was given to you, that means they actually measured it. The zeros are tricky. So the next 3 rules are all about the zeros. Second rule: zeros to the left of the first non-zero digit are never significant. Okay? So for example, if we have 0.012, the 0 is not significant because it's to the left of the first non-zero digit, which is the 1. The 0 is to the left of that, and therefore it's never going to be significant. Next rule, third rule, zeros between non-zero digits are always significant. So if we take a look at a number like 404, the 0 is in between the 2 4s. The 4s are the non-zero digits. It's in between, and so it's always going to be significant. Same thing, doesn't matter where the decimal point is. If it's 0.404 or 4.04, the 0 is still in between the 2 4s, and so it is significant in all those situations. The last rule, the fourth rule, zeros to the right of the last non-zero digit are maybe significant. And how do we know if they're to the right of the last non-zero digit? How do we know if they're significant? You have to look for the decimal point. So the decimal point can be anywhere in the number, and it will indicate that the zeros are significant. For example, 0.400, the zeros are to the right of the non-zero digit, the 4, and because there is a decimal point, that means that they will be significant. Another example, 400, 400. Once again, the zeros are to the right of the 4, and therefore we have to look and see if there's a decimal point. In this case, there is not, and so the zeros are not significant. They're still important. If you don't have them there, 4 is very different than 400. We call them placeholders because they're keeping the 4 in the hundreds place. But because those numbers weren't measured, it means that they're not significant. For example, I walk into the high school gymnasium, I say there are 400 people here. I didn't count the number of tens of people. I'm just kind of estimating 400. And so that's what that number would mean. The 4 was measured, neither the tens nor the units place was measured. So they are not considered significant. There's one significant digit. Let's go through some examples here. First example, you can see 0.00729, and in this example, the zeros are not significant because they are to the left of the first non-zero digit. The 7 is the first non-zero digit, and so the zeros to the left of it are not significant. Therefore, this number has 3 significant digits: the 7, the 2, and the 9. The next number here, we see 729,000. The zeros are to the right of the last non-zero digit. The 9 is the last non-zero digit. The zeros are after that. And so that's to the right. And we then look to see, is there a decimal point? In this case, there is not a decimal point. They were not measured. They're just holding the place, so it's 729,000 instead of 729. So in this case, once again, we have 3 significant digits: the 7, the 2, and the 9. And the zeros are placeholders. Well, what if we actually measured it? And it was 729,000, no 100s, no 10s, and no units. If we measured that, then we just add a decimal like this. Then our rule would tell us the zeros to the right of the last non-zero digit, to the right of the 9, are significant once there's a decimal point. And that's the notation we'll use to show that the zeros were actually measured. Now keep in mind, if the decimal appears somewhere else, as in this example, 7.29000, there to the right of the last non-zero digit. And so since there is a decimal point, even though it's over here between the 7 and the 2, those zeros must have been measured. If you think about it, the only reason to write those zeros is because they were actually measured. They aren't holding any decimal place or anything like that. So, but the rule, to the right of the last non-zero digit, to the right of the 9, there is a decimal point, and therefore they are significant. Finally, we'll put a bunch of zeros in here. We got 0.07020900, and we look at this and we see the first zeros, the zeros to the left of the 7, those are to the left of the first non-zero digit, and therefore they're never significant. So those ones we can just cross out. They're not going to count as significant. Then we see the 0 in between the 7 and the 2. It's in between, so it's always significant. That one is significant. We'll make it green. Pow! Then we have a 0 in between the 2 and the 9. Once again, it's in between non-zero digits, so it is significant. And finally, we have the zeros to the right of the 9, the last non-zero digit. And so those digits to the right of the 9 are only significant if there is a decimal. And we can see there is a decimal, and therefore they are significant. This number has 7 significant digits: the 7, the 0, the 2, the 0, the 9, the 0, and the 0. The first 2 zeros are not significant. All right, the next episode we'll go through how to multiply numbers and keep track of significant digits through multiplication and division. Thanks for tuning in. Catch us next time on the Scientific Adventures of Beardman.